Hey everyone, this video is to help you with adding rational expressions when they have a common denominator. We have another option when they have different denominators. We're going to talk about that in a later video. So for every example here, it's just they have a common denominator. The steps are going to stay the same. Step number 1 isn't going to apply in this video, but we're still going to include it just to keep it consistent. So the first step is you want to rewrite the problem with a common denominator. That means both fractions should have the same number, monomial or polynomial in the denominator. Step number 2, we're going to go ahead and combine. Basically, we're going to add the fractions. Remember, when you are adding fractions, you are only adding the numerators. The denominator stays exactly the same. Once everything that has been combined, you're then going to factor the numerator and denominator. You're going to simplify, and then always, 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 don't forget to list the excluded values. The one thing that makes addition different from what we've seen before, multiplying and dividing, is you factor at the very end. So you factor only after this has become one single fraction. So for the first example, like I said, every single one of these here is going to have a common denominator. So we can go ahead and skip to step 2, which is to add in the numerators. So I combine 13a and 5a to give me 18a, and the denominator stays the same, so over 4a squared. Once you're as a single fraction, you can either factor or just go ahead and cancel out. In this case, we can cancel out because these are both monomials and they can't be factored any further. So starting with our coefficients, 18 and 4 are both divisible by 2, which means the 18 becomes a 9 and the 4 becomes a 2. I have an a in the numerator and I have an a squared in the denominator. Remember, a squared is essentially a times a, which means I can eliminate this a with one of the a's in the denominator. So instead of a to the second, it becomes a to the first, or just a. Which means our final answer for this is 9 over 2a. As far as excluded values go, remember it's only if you've crossed it off and you no longer see that in the denominator. I crossed off an a from the numerator and the denominator. Anytime you cross off a or a squared or a cubed instead of a plus or minus a number, you are essentially having an excluded value of 0. I still see just an a in the denominator. The 2 is just the number being multiplied by it. It's not 2 plus a, it's 2 times a. That is an excluded value of 0. We don't need to list it because we can still see it. All right, for my second example, once again, your denominator is going to be the same. So I'm going to go ahead and combine this. What I mean by that is I'm going to add everything in the numerator together. This first step that I'm currently writing is kind of optional. Whenever I do notes, I like to include extra steps just to keep it a little bit more organized. You're adding everything together. Essentially, you're combining your like terms. So x squared and 21 can't combine with anything, but if you have 8x and 2x, you have 10x. Now that I'm as a single fraction, I can go ahead and factor. So in the numerator, we have a trinomial, which is going to factor to 2 binomials. The two numbers that multiply to 21 and add to 10 are 7 and 3. And in the denominator, this x squared minus 9 is an example of the difference because it's subtraction, of 2 squares, because x squared and 9 are both perfect squares. Anytime it's the difference of 2 squares, It's two parentheses, one with a plus, one with a minus. This should all be factor in review. We ask what squared gets me to x squared? Answer is x, so it comes first. And then what squared gets me to 9? The answer is 3, so it comes second. In doing this, you're essentially canceling out that middle x term. Now that I'm at my most factored form, I can go ahead and eliminate. I have an x plus 3 in the numerator and an x plus 3 in the denominator, which gives me a final answer of x plus 7 over x minus 3 with an excluded value of -3. Because if I plug it in here, -3 plus 3 is going to give me 0, and we can't divide by 0. Once again, I see a lot of students who try to cross these x's off. You cannot divide within addition or subtraction. If these were being multiplied, you could do that, but you can't because it's x plus 7, x minus 3. All right, and for our last example, both of our fractions have the same denominator. I'm going to go ahead and combine them. So 13b squared minus 9b plus b squared plus 2b all over 6b squared minus 5b plus 1. Combining the like terms, I'm going to get 14b squared minus 7b over 6b squared minus 5b plus 1. Whereas a single fraction now, we're going to go ahead and factor. So in the numerator, I can take out a GCF of 7b. Sorry guys. When I take out 7b, I'm going to be left with 2b minus 1. And in the denominator, it's a trinomial. I know that's going to factor to two binomials. It's a little bit trickier because we have a number in front of our b squared. So we're going to focus on this number here. 1 is prime. The only way to multiply to 1 would be 1 times 1. If you're multiplying to a positive number, we know the signs have to be different. We know the signs have to be the same. If this number is minus, this symbol is minus, sorry guys, then we know they both have to be minus. We have options to get to 6. That's going to be 6 times 1 or 2 times 3. If we have 6 and 1, that's going to give us 7 in the middle here. We want it to be 5. So it's going to be 3b minus 1 and 2b minus 1. From here, we can go ahead and eliminate. So I'm going to cross out 2b minus 1 from both the numerator and the denominator. We are left with 7b over 3b minus 1 and an excluded value of b cannot equal. If you struggle with this part of it, all you want to do is you want to take whatever you've crossed out, for example in this case 2b minus 1, and set it not equal to 0. And then solve it like you would any other equation. So I'm going to add 1. So 2b cannot equal 1. Divide by 2. And I get that b cannot equal 1/2. So once again, if it's not really easy to see, take that factor, set it not equal to 0. We have an excluded value of 1/2.